Hey everybody, Dutch Sense here. It is 12:36 a.m. Central Time on Monday, December 19th, 2016. And I'm doing this re-recording, and I'm going to save this on my YouTube video channel for future reference, what I'm about to show you. Okay, take a look at the screen here. What I've just turned on here is something called the microwave background imagery from the MIMIC TPW out of the University of Wisconsin. And this normally shows total precipitation or total precipitable water vapor in the different storm systems around the planet. And it's derived from microwave satellite imagery. And what you're going to see on the screen here is not a storm of any kind that we would normally think of storm forming wise, like precipitation and water. What this is a planetary disturbance of some kind of global shockwave of some kind of energy that is working along the same bandwidths that the satellite is detecting in. That the microwave background imagery at like 35 gigahertz or some large amount, very high up in the electromagnetic spectrum, observing this water vapor is detecting an energy return. This is not a glitch. This is not a computer error. We've seen this happen before, but on a much smaller scale. And when I say smaller scale, I shouldn't say it's too small. We've seen this happen before with X-class solar flares, but nothing like what you're seeing on the screen here now. And let me just show you guys really quick, okay? So we're over here, and let me take you over and show you something from my website, okay? Now, keep in mind, we're looking at the MIMIC TPW right now. I'm going to open up a new screen. And you guys are welcome to search it this way as well. Search MIMIC TPW Dutch Sense Solar. And what you're going to find is a few posts that I put out over the past few years where when a solar flare is happening, a Earth-directed X solar flare, for instance, that hits Earth takes like 2 to 3 days to actually emit those charged particles, and then they come to Earth. It takes a couple days to get here. When the charged particles arrive, what you're going to see on the screen here, and hopefully you guys can hear me and see me here. Okay? See this? Okay, the wave of energy hits. That's the X-class flare taking 2 days to arrive on the planet. There it is, zap. Then we start to have what's called missing data, which is a white area that'll show up. The reason we even use this system to begin with was back when we were doing HAARP research and radio frequency research, specifically in the microwave bands, that we were using this to observe man-made systems such as radar systems, high-powered ship systems that are out in the oceans, observing those using this system unintentionally. It's not an intentional use for it. The only reason it shows up, it's interferometry, it's interfering. There is a microwave signal on the same bandwidth emitted by the sun when the solar flare occurs. The charged particles hit the atmosphere, cause a reflection on the same bandwidth, and that's what causes this. And this was back from 2015, just one example. Okay? But we get over and take a look at the microwave background imagery for today, and you saw the X-class flare. This is so much bigger, so much more powerful. So it's way more powerful than an X-class flare hitting the Earth. And the reason it's taking this S shape across the Earth isn't because it's S shape. It's actually going around the whole planet at once within an hour or two of each other. This reverberation happened last night going up to 3 hours ago, and it probably is still going on right now. And you can see the wave shape that it's taking as it's going across the whole planet. Both sides of the planet are being hit at the same time, letting you know it's affecting the whole planet. And the amount of energy on this, I mean, I want you to think about this. A wave of energy that's returning on the 35 gigahertz microwave background imagery, ultra high frequency, beyond ultra high frequency, and it's showing up across the whole planet all at once. The amount of energy associated with that. For instance, a NEXRAD radar putting out a powerful microwave signal at 2.7 gigahertz. Okay, microwave, not ultra high microwave, but microwave. From, let's say, one of the states in the United States, all right? One of those is putting out 750,000 watts of power, and it doesn't even show up as a blip on this thing. So we're talking about large amounts of energy that would take to perform this amount of interference on the NEXRAD, or on the microwave background imagery that we're seeing here. And the NEXRAD example I just gave you is a perfect example because 750,000 watts is a tremendous amount of power radio frequency wise. It's enough to cover a whole state or two states region. So when you're talking about this getting excited to the level that it's being excited over such a vast area, the energy potential has to go somewhere. So the electricity associated with that, let me dumb it down for everybody. Even a kid can understand this. There's a lot of electricity associated with this wave as it's scuffing its feet across the carpet of the Earth. Have you ever scuffed your feet across the carpet on a dry day and you store up electrons in your body and then you go touch the doorknob? Or if you want to play a joke on your spouse or your sister or brother or whatever, you go touch them on the ear and you zap them, right? With that little amount of scuffing across the carpet. Well, the same thing happens on a much more vast scale with the Earth and charged particles. And as particles scuff their feet across the atmosphere or the upper ionosphere or the magnetosphere, that actually scrapes the electrons out and pulls them down to ground. And instead of shocking your hand on the doorknob, that electricity goes down to the core of the Earth and shocks the core of the Earth. And the energy potential on that is huge. Now, I don't want to get into conspiracy. I don't want to get into crazy talk. I don't want to talk about all the stuff that people have been talking about online recently. This is the biggest dang coincidence in the world, if it is a coincidence. And I'm not willing to discount coincidence. But, look guys, there's a giant wave hitting the Earth right now, showing up on the microwave background imagery, and you really got to wonder, what is causing it? It's not a glitch. Is it a practical joke? You know what I mean? Did one of the people at Mimic watch one of, BP's videos, and you know what I mean? And they're like, oh, we'll make a joke, we'll put it on there, and they put it on there, and they're sitting there laughing right now. I hope scientists don't do that, but this is something that we have to watch. Okay, we have to watch out for what? Well, we have to watch out for the potential of a large earthquake. If, and this is an if, I have to be willing to discount this as some kind of thing that's not going to have an effect, but if it were to have an effect, look at the amount of energy associated with that. If that did have energy associated with it, the amount would be huge. The amount of microwave energy combined to total that. So if that, let me put it in perspective. Let's say there was a man-made system of some kind of new ultra harp. They don't have it, but let's just say they made it, and they made some new breakthrough in radio frequency. And it emitted a giant pulse that was equivalent to 20 trillion megawatts of radio frequency power. That would cook everything around it for miles, and that energy would go to ground. And I dare say it would probably cause an earthquake if it was a man-made system, just doing it over like a country or something. But this is over the whole planet. Will it have a reverberation effect of some kind? A resonance effect? Will it excite the core of the Earth? I don't know. This is all new. I've never seen anything like it before. In 7 years of watching, I've seen all kinds of stuff on the Mimic. All kinds of stuff. Never seen anything like this before. Spanning both sides of the planet. Boy. So, there we are. It is 12:45 a.m. Central Time on December 19, 2016. I dare say we'll know in a week's time whether or not this thing has any effect. I mean, what's the turnaround time for that amount of energy to go down to the core of the Earth? It might be instantaneous. Might be instantaneous, or it might also take a few days. But I'm not going to discount it as a glitch, and certainly we need to pay attention to see if it has some kind of energy discharge effect. Will it excite storms? Will it excite volcanoes? Will it cause earthquakes? Or will there be no effect at all? But certainly we can't discount it. We have to be open-minded in science and realize that there's certain coincidences that do happen. But in this case, I dare say, a global coincidence where all the sensors, everything is messing up? No. Plus, one other thing I'm noticing here as the wave is going across the planet, as it actually stops on those last frames, you'll actually see it form into a dual wave over the West Pacific. And that would make sense if it's real because it's two waves. and they're bunching up on top of each other. You see that? Like two sine waves. You guys ever use an oscilloscope and try to match or pair waves when you're repairing electronics or something? You got two electronics, you hook it up to the oscilloscope, you tune your oscilloscope, it brings the waves into alignment. Now this would be naturally speaking over the whole dang planet. One other thing I would like to point out also before I save this as a video. You see how the S shape is? I want you to imagine the space shuttle trajectory or the International Space Station trajectory over that very same area. And you know that the space station actually rotates around the Earth, right? Okay, and that's why it's shown in that S shape around the planet. Well, that's again, you got to imagine that this is going around all the planet at once. I wish there was a way I could get this overlaid on Earthquake 3D right now on the globe. Maybe there is, but I don't know any way to really match it, guys. But just look at it. I can guarantee you this. BP and the whole crew is going to have a field day with this, and I don't blame them. Because this one confirms kind of what they're saying. It's a global wave of some kind. Oh my God, I can't believe I'm the one who has to come out and say this. Because I was ripping on them so hard. Well, that'll teach me. That'll teach me. You know, okay, there I go. I learned my lesson. I will never mock or ridicule anything about anything anymore until I see proof of it. How about that? I probably should have held my tongue till December 26th, right? Oh, dude, what did I just... Okay, if it's going to hit in the next week, if any kind of earthquake was going to hit in the next week, it would be hitting by December 26th. Oh, my God. Okay, all right, we're going to end it there. I'm going to save this as a video. Get this out, get the warning out, I suppose. Let people know it's going down. You can stand by it. It's not a glitch. It's not a computer malfunction. Maybe somebody's playing a joke on us at Mimic. That's the only thing I could think. Maybe somebody's got wind of that whole conspiracy online about the galactic wave and decided to have some fun. But other than that, I would dare say it's real. Unless somebody's messing around and putting this on the feed, it's real. And if it's real, then we got a problem. Or at least we got a potential problem developing here right now. What it is, I don't know. The cause, I have no clue. Something, look, I don't know if the sun doing anything major right now. Let's go check here. Hold on. Let's go check the GOES X-ray flux. What? Flex. Okay, there we go. I mistyped. GOES X-ray flexing. All right, calm. Let's check the total electron count. Total electron content. Low, man. Low. Or wait, is this real time? That's not real time. Hold on. I was going to say, that looks low. Can we get some real-time data, Noah? Oh my God, really? Okay, let's check Trimble. Does Trimble have an ionospheric map that we can use? Does anybody have an ionospheric map? Is this real-time? Yes, this is real-time. Okay. Nothing major. Nothing major showing on total electron count. Well, okay. All right. Well, there we go. Okay, so guys, there's our update. I will get this out to the world. Hopefully you heard me. Hopefully you heard me. I hear people in the chat room saying they can't hear me again. Why can't I hear Dutch? I don't see anybody else saying... Okay, I don't see anybody else saying they can't hear me. So... Has everybody else been able to hear me? Okay, all right, so here we go. I mean, you guys have seen it. I'm going to go save this as a video on my channel, and you guys are welcome to share it. And oh, by the way, guys, it's not a coronal hole or an open solar stream. This is something greater. It's greater than an X flare. It's greater than the solar wind. Oh, you know what? We could go check the solar wind. I didn't think to check the solar wind. Hold on. Oh, solar storm, solar wind. I should have the link. I'm lazy. Okay. Solar storm, solar wind. Space weather. All right, let's go see. Yeah, it's nothing too strong. I mean, nothing major going on here. I mean, it is. There's not going to cause that. This is a galactic wave. I said it. All right, I'm going to save it, guys. Much love.